Hi friends, welcome back to my Fire Factor channel. Today video I will discuss about refrigeration air conditioning system, its cycle, how is it working and which components are associated with the system. Okay, so in the system, refrigeration system, its main parts are associated with the system. What is that? So main parts are compressor, discharge line, condenser, liquid receiver, strainer, and liquid line, metering device means that is expansion valve, evaporator, accumulator, and section line. So these all the components, these equipments are connected in series with the help of tubes or pipes. So friends, so in this system, complete system is charged with a refrigerant like that is R22, that is 300, 304A, 404A. So this is all are the refrigerant, and there is a freon group, and also there is a some of refrigerant is ammonia refrigerant is there. So this is charged with this refrigerant. Okay, so friends, next, so how is it working? So when the motor, compressor motor is on, the compressors suck the low pressure, temperature refrigerant vapor from the evaporator through the section line and compress the high pressure, high temperature refrigerant vapor into the condenser through the discharge line. So this is the main working in the compressor. So in this condenser, when it is reached to the condenser, the condenser high pressure, high temperature refrigerant vapor reject the heat, the sensible heat, that is sensible heat and latent heat, to the external cooling media. So what is the external cooling media? It may be it is the air, and is the air cooling media or water cooling media. So then the refrigerant is condensed and flows into the liquid receiver. Okay, when the high pressure, high temperature refrigerant reject heat, it is coming to the liquid stage, and it is enter into the liquid receiver. Okay, so this liquid receiver, the collected liquid, then it is passed through the liquid line and dry strainer. When it is going to the dry strainer, the dry strainer working is to remove the moisture and any dust or chemical particles from the refrigerant. So this is the strainer purpose. After the dry strainer is the pure liquid refrigerant flows into the small hole of the expansion valve. Okay, the expansion, there is a thermostatic expansion or a capillary tube expansion is as per the design is installed. The liquid is passed through the small hole of the expansion valve. So at the outlet of the expansion valve, the pressure of the liquid refrigerant is reduced, and it is reduced low pressure, low temperature. So this liquid refrigerant flows into the evaporator. So once it is flows into the evaporator, what will happen? The low pressure, low refrigerant observe the heat from the surrounding space where the evaporator is located. Okay, so then the surrounding, the space is to be cooled. So after the evaporation process, the refrigerant is comes into the vapor state. That vapor state refrigerant, the vapor refrigerant flows into the compressor through the section lines. Okay, so during the evaporation, there is some of liquid remain, it is completely not vaporized, so that liquid is stored on the accumulator. So this is the main purpose of accumulator. So this cycle is repeated again and again. This is the main working principle of refrigeration cycle. So friends, I hope you understood the concept. So one more thing I have to add here, why the oil separator are fixed here, because during compression some of oil also is flashing with the refrigerant, so that oil is separated on the oil separator. If it separator is not there, this oil, if the oil is flows into the condenser, refrigerant will not condense properly. That's why the oil separator are fixed between the compressor and condenser. Okay, and then it is comes to liquid receiver, already I explained. So friends, this is today video. So we'll see with another video. If you not subscribe the channel, please subscribe and share to upcoming video notification. So friends, thank you so much for watching this video. See you, take care. We'll see you with another video.